This conference will now be recorded.
Hi, good morning, everyone. So, if you, I think we have to start with Kubernetes architecture. So, let us get started with that. So, in Kubernetes, right, we have two components which I've told you yesterday. It's like control plane and compute plane, or we can call it as master node or worker node. When the days passed, the naming convention has been changed actually. Initially, when Kubernetes was released, right, we used to technically call it as master and minion. Okay, when 2016 15, in those days is actually we used to call this one as master and this one used to minion. After that they have changed into master slave, and now they are calling them into control plane and compute plane. Okay, now the current terminology that we use to call these particular nodes are called as control plane, and the worker nodes are called as, or the minion nodes are called as compute plane. Okay, so that's how it is. Though the names have been changed, but the purpose of that particular nodes are the same. Okay, just to make a note of it. Now, what are the components that will be running on the master node or the control plane node, and what are the components that will be running inside the compute plane node? Okay, so that we have to understand, because all the components will not be, when you try to install Kubernetes, not, it doesn't mean that all the components what are running on the control plane will be running in the compute plane. No, it's not like that. Okay, why? Because this is called as controller and these are called as compute, where your actual applications will be running, and your control plane will control the entire cluster. What is a cluster? Grouping multiple nodes together and bringing them under one platform is called as cluster. Okay, so who will control from that particular central location? The controlled, that particular node is called as control plane node, from where you manage your entire cluster or from where you deploy your applications from the single node. That is called as control plane. And the compute plane is nothing but where your actual applications will get deployed. Okay, it will be running here, or it will be running here, or it will be running here. It takes a decision. Okay, how these things will happen, let us try to understand one by one. Now, in the first time when someone is asking in interview, they will ask you what are the components that are running on control plane node, what are the components that will be running on the compute plane node. Okay, what you have to tell is, on all the nodes of your cluster, how many nodes you are using for your Kubernetes cluster. On all the nodes, the first component which we have to install is container runtime interface. Container runtime interface, that has to be there first of all. Before forming your Kubernetes cluster, first of all you have to decide which container runtime you have to use, and that you have to deploy. What is container runtime? Which container tool you want to use? Do you want to use Docker? Do you want to use containerd? Do you want to use Creo? Do you want to use rtx-d, or do you want to use any other component? Okay, so like, you have to take a decision first. So according to the current running situation and in production, it is recommended to use containerd. Container d Docker got deprecated, as I told you before. In 1.24 completely you cannot use Docker. Okay, that is for sure. Now it might support in 1.23, till 1.23 it might support, but after 1.23 you cannot see a Docker which is running behind your Kubernetes to create a containers. Okay, so let us get habituated to the latest what do you say, the changes that is happening in Kubernetes. We have to adopt that particular changes. Okay, later I will tell you why they have deprecated Docker, why they are using only containerd. Okay, what is advantage that we get, all these things. Okay, but we have to learn Docker. Why? Because in order to build the images, in order to push the images, so Docker is the only tool which we have to build the images properly. Okay, so that's a fundamental which we have to learn and which is important for us. Now coming to the point of components that are running on the master node or the control plane node are nothing but Kube API server, control manager, etcd, and Kube scheduler. Apart from your, what do you say, the container runtime interfaces. Okay, the components which makes a difference called as control manager, Kube API server, etcd, and scheduler. Okay, so wherever you try to deploy, whether it is cloud or whether it is on premises, these components are same. What is the difference between cloud and on-premises is nothing but this particular control plane node will be managed by your Azure. You don't need to take care of it. They will take care of this. Okay, you don't have access to this particular control plane node. You'll have access only to the compute plane nodes, which is called as node pool. Okay, we'll discuss that later. But if you are deploying your Kubernetes cluster on premises, you will have control plane node and you will have compute plane nodes. Okay, now in the control plane node, I have told you these are the components which we have. So which component is responsible first? Means whenever I try to interact to my Kubernetes cluster by using API call or by using the YAML file, declarative or imperative, or if I am using CLI command, which component will respond first? Okay, the first component which will respond is nothing but Kube API server. So Kube API server will take the information, okay, whatever you have passed, whether it is from CLI, whether it is from the dashboard, or whether it is from the YAML file what you have written, whatever the mechanism it is, the first component who will take the information is API server. What it will do, it will verify the YAML file or the details what you have written or who is trying to communicate, because everybody cannot create application on my Kubernetes cluster, right? First I have to verify him, means I have to verify authentication and authorization. That is the first thing which will be happened by your Kubernetes API server. Okay, so it will verify the authentication and authorization. If both are passed, then it will validate your YAML file. If you have written the YAML file, it will validate your schema, whether all the parameters what you have written in the YAML file are correct or not. All these things will be verified. Okay, once that is also done, then it will go to the etcd. Okay, if you are trying to deploy some application, it will verify that application is already available or not. If it is not available, it will add the details into the etcd, and then it will go to the next phase, means it will send an acknowledgement. After that it will go to the next phase, your API server. Okay, now that's how it is. So the first component who will be responsible for your Kubernetes cluster is API server, API. That's it. That's the main component who will receive the information first. Okay, and then etcd is a storage in the sense entire your Kubernetes related information is stored in your etcd. Entire metadata information of your entire cluster of your Kubernetes is stored in etcd. That's the reason why we have to take a backup of this, which is so important. Okay, always you have to take a backup of this particular etcd. Okay, which is so important, because if the data is corrupted, right, or if this particular component is not running, your entire cluster is not accessible. Okay, so you have to be careful with the this particular component which is so important. And it is not a database, it's a key value pair storage. So what are the other storages that we have similar to it is nothing but console, CONSUL, console, Zookeeper. These are the best examples for your key value pair storage. Among this, etcd is the recommended one from the Kubernetes. If you want, you can use other third-party tools as well. Okay, but the recommended one from Kubernetes community is etcd. Okay, now it will store the information. After that it will send the acknowledgement, and then your API server will receive that acknowledgement. After that, what your API server will do, let's say it is trying to launch some application. So your Kube API server will pass the information to the scheduler, and scheduler will decide on which node this particular application should be running. How it will take a decision, it will see like how many pods are running on each and every node, what pod let's say what application you are trying to deploy, how much resource it will consume. Based on that, it will do some calculations, and it will decide out of these three worker nodes or compute plane nodes, it will decide which compute plane is suitable for launching this application. That decision will be taken care by your kube scheduler. Okay, so that is done by your kube scheduler. Okay, that's a responsible, that's it, it doesn't do anything else. So it will collect the information from the etcd, and it will see how many nodes are there and which node is having how many pods, and based on that it will take a decision to launch that pod on that particular uh, uh, compute plane node. Okay, pod and all I will tell you later, but application, let's assume that it is an application. Okay, now after that the decision has been made. Now one more question is, how your etcd will come to know that I have these many compute nodes, these many pods are running, each pods are in this particular status. How this information will be known by your etcd? Etcd is just a key value pair store. It doesn't do anything else apart from this. So there is some other component who is fetching this information and giving it to your etcd. That component is nothing but control manager. Okay, so it will fetch the entire cluster related information and it will give it to the etcd. Okay, that's how it is. And not only that, if something goes wrong in the, let's say I'm expecting one application to be running and that went down, so your control manager will come to know it and it will intimate to the API server that one of the pod is not running as expected. Okay, or one of the application is not running as expected. So then based on that, it will take a decision and it will launch another application to satisfy the condition. Okay, so this is the control manager responsibility. So it will collect the entire cluster related information status and that will be given to the API and API will store the information to the etcd. Okay, so these are the responsibilities of these four components. If you see the components, these two components are not talking with each other and these two components are not talking with each other and these two components are not talking with each other directly. They have to communicate with the help of API server. They have to communicate only with the help of API server. They cannot communicate with each other directly. No, it is not possible because there is an authentication mechanism. So after the authentication was validated, then only it has to pass the information. So these components cannot talk to each other directly. Okay, so that's how the components that are running on the what do you say on the control plane node. In cloud, it is called as cloud control plane node control manager, but in on-premises it is called as kube control manager. That's it. That's the only difference in the name. Okay, whether you take Azure Kubernetes Cluster or whether you take Google Kubernetes Cluster or AWS Kubernetes Cluster, whatever it is, any Kubernetes cluster, the components and the responsibility are the same. Okay, in the cloud, we don't manage this particular node. This will be managed by your cloud. Okay, but in on-premises, we have to manage this particular node as well. Since this particular node is so important, that's the reason why we will try to create at least 2 to 3 control plane nodes actually. Why? Because it has to be highly available. Highly available in the sense, if one of the master node is down or the control plane is down, I cannot access my Kubernetes cluster, right? So though applications are running, I cannot access them or I cannot manage the cluster. I cannot deploy any new application. If something goes wrong, it cannot be controlled. So it is like mess, right? So that's the reason we will deploy this particular node as a high available in the sense at least 3 control plane nodes. If I need to do it, I have to take a lot of headache, like I have to take care of this, I need to know how to form a highly available, okay, all these things I have to take care. In the cloud, automatically these nodes will be formed as a highly available cluster. Okay, so this is highly available. Master nodes will be created by your cloud. You no need to take care of it. But if you are doing on-premises Kubernetes cluster, we have to ensure that your control plane is running at least with 3 nodes. With 3 nodes, that is enough actually. For managing 500 worker nodes, 3 control plane nodes are enough actually, highly available. Okay, so you will be using a load balancer before them to the control what to say control plane nodes. Okay, so all these things are called as highly available. Okay, right now I cannot do that, so that's the reason I will be using only one control plane node and one compute plane node for testing purpose in on premises. Okay, so next thing is, okay, the decision has been made that the application has to run here or here or here, whatever it is, any compute plane. Okay, every compute plane has the same components. Now, what it will do after reaching to this particular node, who will receive the information first? The first component who will receive the information is nothing but Kubelet, Kubernetes related component, which is called as Kubelet. So Kubelet is the first component who will receive the information from your API server on your compute plane node. It cannot talk to your container runtime directly to deploy that application. First, it will pass information to the kubelet, and kubelet will pass information to your container runtime, whether it is a Docker, whether it is a containerd, whether it is a Creo or whatever it is. It will pass information to that. Then it will create a container for you in the backend. Okay, so directly this API server is not talking to the container runtime. So it is passing the information to the kubelet, and kubelet is passing the information to your container runtime interface. Okay. And what is the responsibility of kubeproxy? It's a proxy server where it will bypass the information of your network. Let's say if you are trying to communicate from your external internet to your application, first it will reach to the node. From the node it will reach to the respective application with the help of kubeproxy. So kubeproxy knows how to divert the traffic, or how to send the traffic to the respective components. That is the responsibility of kubeproxy. And remember, kubelet and kubeproxy will be there in the master node as well, in the control plane node as well. Okay. Apart from your this particular components, it will have kubelet and kubeproxy. Why? Because there will be some applications which will be running in the control plane node as well. See, these nodes, these components will be running as a pods in the containers inside the cluster. These are not like a services. Okay, this will be running as a containers, except your kubelet. Kubelet will be running on all the nodes, whether it is a control plane node or compute plane node. All these components, this kubelet component will be running as a system D, as a service. All other components will be running as a containers. Technically in Kubernetes it is called as pod. I'll tell you what is pod and all in the next session. Now this is what it is. Okay. Now how will you create a Kubernetes cluster? Tomorrow we will see on-premises, maybe in the next session. Today let us try to see how to create a Kubernetes cluster in AWS. Sorry, not AWS, sorry, my bad, Azure. Okay. I think I show Kubernetes cluster on-premises rather than the cloud first. Yeah, let me try to do it. But before that I have to do something, because I need to create two nodes. It should have two operating system to be installed, and then I have to install container runtime. Then I have to install my Kubernetes application. So instead of wasting the time over there, let us try to use Kubernetes cluster on the Azure cloud side. Okay. Tomorrow I'll show, means late in the next upcoming classes, I'll show about how to create a Kubernetes cluster in your on-premises in the sense in your own laptop. Okay. Now Kubernetes, the main, if you want to deploy some application on Kubernetes, that particular first component is called as pod is nothing but, I'll tell you what is pod and all, but that is nothing but a pod. If you want to run an application on Kubernetes cluster, it is not called as container, it is called as pod. In Docker it is called as containers, but here it is called as pod. If you see, in Docker Compose it is called as service, right? Technically the name got changed, but the container is a container, that's it. Okay. Since we are trying to create your container through the Kubernetes, so that's the reason it is called as pod. It's not that simple, it is beyond that actually. Okay, so we'll see that later what is that. So this is a simple YAML file which I have written for reference. We will try to understand each and every parameter which we have written in the YAML file. Okay. So this is the flow which I've told you. Whatever I explained right now, everything, this is the flow chart. When you try to create a pod, nothing but an application, it will go to the etcd, and then it will send an acknowledgement. Okay. And if it is already there, it will send to the user saying that this application already exists. If it is not there, then it will go to the scheduler, and scheduler will decide, it will collect the information from the etcd. How many pods are there, how many nodes are there, how many pods are running on each node. All this information will be collected from your etcd, because etcd is the only component, right, who is storing the entire cluster related information. So that's how. So it will get the information, okay, with the help of API server, and then it will send it back to the scheduler. Scheduler will take a decision, and that decision will be given back to the API server, and then it will go to the that particular compute node. It will go to that particular compute node, and the kubelet will pass information to the Docker or any other component, and then it will send an acknowledgement. From here it will send an acknowledgement, it will update the details in the etcd, like whether it is successfully created or not, and then the end user will get the update whether that application is successfully deployed or not. So this is the flow chart. Okay. I hope these components and everything is clear. Have you understood each and every component in Kubernetes, or any doubts? so that we can go to the Azure Kubernetes cluster creation. So if you look at your Azure Kubernetes architecture as well, it's the same. You can see this is managed by Azure. You no need to worry about it. Okay. So this is managed by Azure, and these are the nodes which are managed by us. Okay, customer managed, Azure managed. Okay, nodes are nothing but run your application workloads. Control plane provides the core Kubernetes services and orchestration of application workloads. Same thing. You can see the components. Same. Did they change anything? No. Whoever tries to deploy, creates a cluster in the cloud, it's the same technology, same components. You can see there, same components. Okay. So now let us go back. Okay, and let's create a cluster. Any other questions before I go to the next level? I hope everybody is clear with the components, each and every component which I've explained.
So can we run this control plane node in on-premise and the worker loads like the pods in Azure? Is that possible or?
Compute planes on Azure in the sense what? Is it a virtual machine or what?
No, can you just go back to the architecture once, please?
Okay.
Here you're talking about the master node, right?
Yes.
This master node, is this possibility like we run this one in on-premise and all the
Okay.
worker nodes, worker nodes
Hmm.
in Azure?
But see, one thing, how will you create your Kubernetes cluster, right? Let's say, for example, here we have to use something called add Kubernetes cluster with Azure Arc. Azure Arc in the sense which your Kubernetes cluster will be created in your on-premises, but it is managed from here. If you want that, you can use this one. But
Okay.
this cannot be maintained in your on-premises, and this cannot be created in your Kubernetes cluster service. You can use this one as a virtual machine in Azure, but not like a Kubernetes cluster. Okay, you
Yes,
cannot
sir.
use that service. Is that answering your question? Yeah. So this is one of the thing. Okay, so where like if you have your local machines and you have to want to manage from here, you can manage from here. Okay, your on-premises cluster. But right now we are creating a Kubernetes cluster in Azure data center. Okay, if you want to create that, first of all you have to search with Kubernetes like this. Then you'll get Kubernetes services. Click on that. Then you have to click on create and then create a Kubernetes cluster. Click on this particular option. After this, what we have to do, under which resource group and under which subscription you want to create this service, then you have to. I generally use to the demo. Okay, cluster preset configuration. It is a standard for dev testing or for cost optimization or batch processing or what. These are the new things they have added. Earlier we don't have this particular thing actually. Okay, if you are not sure what to choose, works well with the most applications. If you don't know anything, like don't know whether I'm using for dev test environment or whether I'm using for optimization, cost optimization or batch processing or what it is, I don't know anything about it. Okay, then you can compare here what you get here, how many nodes you can see, system node pool node size, what node size you get here. Okay, so what node size you get here, what node size you get here. This is the thing which they have added recently. Okay, so I have not seen this earlier. This is the recent one they have added. So it is up to you which one you want to. Okay. Hard-end access is nothing but you can see private cluster, you can create availability zones. Okay. Azure policy, Azure monitoring, secret storage, all these things. Monitoring, cluster auto scaling, availability zones can be done here. But if you want to create a private Kubernetes cluster, then you cannot do it here. You have to use hardened access. Okay, based on your requirement you have to use this. Okay, based on that also the billing will get changed. Okay, that's a I think that's a goal why they have divided this into a separate what is a plan. It's like a plan, right? Standard plan, dev test plan, cost optimization plan, batch processing, and hardened access. Okay, so whichever you want to use, you can use it. Let's say I want to use this one. Okay, so let's say I will select this, and then let's say apply. You can see that a quick to quickly customize your Kubernetes cluster, choose one of the preset configuration above. You can modify this configuration at any time. So I'm okay, right? See, anytime I can modify this, so I'm happy with this. So no need to worry too much about that. Okay, unfortunately I selected this. Now I realize that okay, we need hardened access. No, you can change it at any point of time. Okay, after the cluster has been created. Simple, they will enable that options. That's it. So it's not that you have to recreate the cluster in the background, right? They will enable that options. So it will take few minutes to reflect that particular changes. That's the only difference. Okay. What is the cluster name that you want to give? Let's say I want to give simple. So we are hyphen demo. That's it. Okay. Now, in which region you want to create this? Means in which region you want to place this particular Kubernetes cluster. In which availability zones means in which data centers you want to put. Okay, so that highly available, if one data center is gone, still you can access your Kubernetes cluster from another data center. I told you, right, the control plane has to be highly available. How this will happen? Only when you select this kind of approach. Okay, and which Kubernetes version is deploying right now? It is in preview stage, this one, and at least by default this will get deployed. If you want, you can go here 1.22.6. If you want to see the latest version of Kubernetes, always try to look at the official document. Don't search anywhere. You can look at the official document. Right now it is 1.23, but here they are not supporting it 1.23 right now. Okay, you can, if you want, you can see it is in preview stage. It is not ready for production. Okay, so you have to read about that as well. Next, it is telling that API server availability will be 99.95%. Okay, your Kubernetes API server will be highly available and there will be no downtime. Okay, until unless if all the zones in that data set in that region are down. If that is a worst case happen, then there will be some downtime, but you cannot expect, right? Okay, so we cannot say that all the data centers will be up and running in a region. In that entire region, if there is something happen, then all the data centers are shut down. So that could happen. The worst case it is. Okay, that's the reason it is 0.05 worst condition it is. So what is the size that has got selected automatically? 4 vCPUs and 16 GB RAM memory, which means that what are the nodes it tries to create in the backend, the compute nodes. Okay, the compute nodes which will be created in the backend will have the capacity, the resource capacity as 4 GB RAM, sorry, 4 vCPUs and 16 GB of RAM. Okay, if you want to change this, you can click on change size and you can come up here. If you want more, you can select this one. If you want this, you can select this. Okay, it's up to you which one you want to select. Let's say I selected this one. Okay, auto scale. What is a scaling method? What is the purpose of this?
Increase and decrease the number of nodes running.
Yeah, so the number of compute nodes, right? Based on the load or based on the capacity. Let's say I have run all the applications. Let's say right now I'm using only one compute node. So many applications got deployed. Now there is no resource left here to run more applications. Now what Kubernetes will try to do, it will launch another worker node, another compute node, and then your new applications will get deployed here. So if you want that approach of auto scaling, then we have to use this. What is the minimum and what is the maximum? So maximum I just want to give 3 and the minimum is just 1. Okay, that's it. And now this is how. If you want to manually scale, then you can use it. If you want auto scale, auto scale. In general, let us try to use auto scale because in productions we cannot take a risk like I have to do it manually. Okay, and then node pool. So how many node pools you want to create? Here you can see agent pool. By default it is having 1 to 3 nodes. Okay, and there is user pool. User pool I don't want to create it actually. Let it be system pool. User pool in the sense which we are trying to create. Okay, it is from 0 to 5. Okay, let it be like that. User node pool is recommended for hardening access configuration. Okay, so if you want any other pool in the sense, I want to combine couple of nodes under one pool. Now these two nodes will be one pool, other two nodes will be one pool, and other two nodes will be one pool. Why we create a pool like this? Because let's say in this pool, these two compute nodes are having high-end configurations like Intel processor, 1 terabyte of hard disk. Sorry, let's say 100 terabyte of hard disk, 1 terabyte of RAM. There are some high-end configurations. Okay, then I want to club that particular nodes together under one pool. Okay, so that I can manage my application deployment in a proper way. Okay, and I want to pick other two nodes which are like less configuration, maybe 1 terabyte of hard disk and 20 GB of RAM, something like that. Then I want to put them in under one pool. So if you want to segregate your compute nodes, then you have to create a pool. Okay, if you want to add more pool, just click on add pool and you can select whatever you want. Okay, so maximum number of containers, you can call it as like pod. I will say like here you have to remember that it is a pod in Kubernetes. Okay, the maximum number of pods that are recommended per node is 110, or you can increase up to 250, 10 to 250. If you want you can increase, but the recommended one is 110. Okay, I'll tell you why it is 110 and all. Okay, for now leave it as it is. Okay, it is asking, do you want to use virtual nodes? Virtual node in the sense, simple, I will tell you. I don't want to create a nodes, compute nodes. I don't want to manage this particular nodes. It has to be taken care by your Azure. I just want to deploy the pod. That's it, which is called a serverless architecture. Serverless architecture in the sense, I'm not worried about underlying infrastructure. That has to be maintained by Azure. Like how this master is maintained, I want a worker compute node also should be maintained by your Azure. I just want to deploy my application. That's it. If you want that particular thing, then you have to enable this virtual nodes. Okay, so in the backend it will take the help of Azure container instances. Why I've told you that? Because I just want to explain what is virtual nodes. So that's the reason. Now I've covered this before. What is Azure container instance, you know, right? The purpose of it, that will be used in the backend by this virtual nodes. Virtual nodes in the sense, you don't manage this like how you're managing here, right? You don't manage this particular nodes. That will be managed by your Azure. You just tell what applications you want to deploy. That's it. Okay, and based on the requirement, it will scale. Okay, it will increase the size of your node in the backend. Okay, that's the best thing we have. Okay, node OS disk encryption, if you want you can just enable, let it be as it is. And then do you want to enable the RBAC? I told you, right? Kubernetes authentication and authorization. Do you want to use RBAC? That is for authorization actually. Or do you want to use authentication by your Azure Active Directory? Then you can enable this option, which means that your what are the users I try to create in Azure Active Directory, those can authenticate to my Kubernetes cluster. If you want to enable like that, then you have to enable this option. Okay, remember, once this option is enabled, you cannot disable it. After the Kubernetes cluster is created, you cannot disable this. So you have to be careful. Look at this. Once this feature is enabled, it cannot be disabled. So you have to take a decision before doing this. Okay. Right now it is not a concern for me, so I don't enable this. If I want, I will enable later. But if I want to disable, I cannot do it later. So that's the reason I'm not enabled this right now. Okay. Then networking. So let it leave as it is. I'm not worried about this right now. So you should also leave it as it is. Later I will explain what is Kubelet and what is Azure CNI. Okay, right now it is using Azure CNI for networking for your Kubernetes cluster. Okay, enable private cluster. Do you want to use private cluster, which is a recommended for hardening? But if you want, you can enable as public. Public in the sense you can access. Okay, so right now I'm not using a private cluster, which is recommended for hardening access configuration. Right now I'm not using it. I'm using public cluster. Later I will show you how to create a private Kubernetes cluster, how will you access them, what things you have to follow, all the things. Okay, set authorization IP range. Let's say you want to allow only the people who are from specific IP range to connect to your Kubernetes cluster. then you can enable this option and you can specify the IP range. Let's say you are connecting to your Kubernetes cluster from your on-premises network. Then I want to allow only that particular network to connect. So if someone is trying to connect to your Kubernetes cluster from any other network, it will reject. If you want that functionality, you can enable this, but you have to specify the IP range. Okay. Now, which type of network policy you are using right now? Calico. Let it be as it is. I don't want to change it. Now, next, integration monitoring. If you want to integrate your container registry, you can do it. Right now, I'm not doing it. We will see that later. Monitoring is enabled by default, which is so important. Azure policy is also enabled. Let it be like that. Advanced. CSI driver, let it be like that. Okay. And then review creator. So these are the things which we have to enable for the initial Kubernetes cluster creation in Azure. They
So
have
what is
changed a
this
lot.
DNS server IP address Kubernetes? Is that our Azure DNS IP or is it something different?
Which one you are talking about? Okay, Kubernetes
Kubernetes.
DNS. Oh, okay, it is Kubernetes DNS. I will tell you this. This you will come to know when you are using service component in Kubernetes. There is a object called service. There you will come
Okay.
to know what is this DNS service IP address range. Okay.
Because generally we do have DNS in our, once we create our site, we do have our
Yes.
DNS, right? Is that DNS
Yes.
same
No, no,
internal?
no, no,
Is
no. It's internal Kubernetes. Okay.
Oh, okay, okay.
Oh, validation got failed. Let's see, guys. The validation got failed. What went wrong? It is telling you that quota exceeded. Quota exceeded. How come? Okay, new limit request 24. Submit a request for quota increase at. I think I have created so many times a Kubernetes cluster. This is strange actually. Earlier we don't have this. Now I think we need to raise a request. Okay, send a request to them saying that please increase the quota to create a Kubernetes clusters. Okay. See this carefully. What is the message? And the main error is quota exceeded. So provisioning a resource for a container services Sudhi demo in resource group Sudhi DevOps failed. Okay, message operation and all. Okay, let me do one thing. Let me go back to the basic and let me try to create a new one and see what it will tell. Let's say AKS hyphen visual part demo. This is the new resource group which I want to create. Let's see what happens then. Rest of the components are I've selected as it is still there. Okay, in the cache. So validation has to pass. If that is the case, then I have to raise a request. There is no other choice for me. If this quota issue is in the subscription level, I have to raise a request to the Azure team, or else, yeah. So it is quota is like that level actually. Oh my God. Let me see. I've never seen. This is the first time which I'm seeing it. Every time I used to create it, Kubernetes cluster and all. Now this quotas and all this got increased. I have to check this. So under your subscription, you have to go for your settings, usage and quotas. Okay. Let's see how much I've used. Let me search for Kubernetes. Okay. Let me search for compute usage. Oh, okay, okay. This is like standard D1, D2, D3. Okay. Let me do one thing. Let me go to the nodes. Here, what I'm using right now. Let me change this size. I go for the least one. Let me go for this. That would be better. And one more thing is, I don't want to use this additional pool. Let me delete this. And this one, instead of 3, let it make it 2. That is sufficient. Okay. Okay. I'm thinking this should solve the problem. Let's see. Yeah. Now we can see, right? Validation passed. Okay. This is something where With this many nodes, it is not allowed for me to use that but thing. Okay, so I have to increase the quota, I have to raise a request to them and all. Okay, now create. Same parameters. See, this parameters what I've selected as same as it is. Nothing has been changed. So it is, you can see it is creating a new virtual network, subnets and all. Okay, we'll see that in detail one by one later. But right now I just want to create a Kubernetes cluster in Azure. So what you have to follow, these are the steps. This is so simple, right? For me it is not needed like think about, okay, I have to plan about network, okay, I have to plan about how many nodes I need, okay, how many control nodes I need how to install the operating system, how to install Kubernetes, how to install runtime. All these headaches are not needed from my end right now. Why? Because cloud is doing it for me. I'm selecting what I want, which version of Kubernetes I want, what should be enabled, what should not be enabled. I'm just selecting that. Based on that, my cluster will get created in the backend. So easy to do it, right? But in on premises, we have to plan everything. That's where you will learn the basics. Okay. This will suppress your knowledge. That's what I say all the time.
Sir, in the node, what you are creating, like you have given two nodes you are going to create, right? In that,
Yes.
those nodes, you are going to run the serverless computing architecture, which
No,
are
no, no.
called
We are
pods.
not using virtual nodes, right? These are virtual machines which will be created in the backend.
Okay. Yeah, in the nodes, you are going to create pods. Is my understanding correct?
Yes. Yes, yes,
Okay.
exactly. That's where you will be running your applications. Okay. Not on the
Okay.
master node. Why? Because master node access we don't have, right? It is maintained by your Azure. Okay. You cannot
Okay.
deploy any application on it. Whatever the application you deploy, that will go into your worker nodes.
Okay. So nothing but it's like a infrastructure, one
Yeah,
component,
this is
and
maintained by your
the
Azure, and
workloads.
this is what you are using right now to launch your applications, the compute
Oh,
nodes, which are called as
okay.
node pools.
Okay, sir.
Yeah. Even if you go to AWS Azure, it's the same thing. This will be managed by your AWS, and this is the access what you will have EC2 instances. If you go to Google Cloud, you will have this will be accessed by your Google, and this will be you will be accessing with the help of compute engine. That's it. It will take few minutes to complete. Why? Because it has to create a lot of things in the backend. Okay, obviously it's not a simple virtual machine, right? It's a cluster. It has to take care of so many things in the backend. I think this is enough for today. I don't want to go much details about it, but you try to create it and delete it immediately. Like once you see the view of that cluster, right, just delete it. Okay, later if you want again you can create it. It doesn't take much time, right? 5 minutes maximum. That's it. From one batch to another batch, I see a lot of changes in Azure. So that's the reason why I see some changes which are happening. The one thing which we have observed, right, while creating the cluster, the first one, it has asked to select the deployment type, standard, dev test, hardening system.
Sir, you creating new virtual network? We can even deploy in the existing VNet, right, sir?
We can use the existing one, but right now it is creating the one. Okay, it is creating it. You can say the virtual network is getting created and the name is AKS Visual Path Demo hyphen VNet.
Okay.
In general, it has to be like a prerequisite with whatever the subnets you want, all these things. It's a plan. Okay, we'll see that later. Like how will you do it from scratch, each and everything. Since I have not teached about virtual network, right? If I say now, everybody will get confused. So I don't
So
want to fall into that. You can say how many, what do you say, resource types it is calling. This is one resource type. I told you in the starting session, like what is resource type and what is resource group. Okay. You can say now it is done, right? So go back to this, and now you can say this is the dashboard of your Kubernetes cluster. Now, how will you access it? That's the next question which everybody might have. Whenever you don't know that, just see here there is a option called connect in overview. These are the steps which you have to follow in order to connect. If you want to deploy some sample application, if you want, you can test it. Okay. For now, let me show you how to connect to your Kubernetes cluster. So, yes, let me try to do it from my Windows. Why can't I do it? Let me just open my command prompt. Let me see if I have agent commands executable. Yeah, it is already installed. If you want to install, right, visit CLI install. Just follow this documentation. That's it. Okay, just download the MSI Microsoft installer and just install it. That's it. If you want to follow the CLI commands in PowerShell, just follow these commands. Once it is done, right, you will see this particular CLI installed. Okay, AZ version. You'll see which version I'm using right now, 2.28. Okay. Now, first command, what I have to do? I have to execute this command. Okay. So here, what it is trying to say, open the cloud shell or a AZCLI, run the following command. Okay. So take this, go to this, and enter. What it is trying to say does not exist in the cloud. So what you have to do? Does anyone have some idea? There is one command that I'm missing before this. What is that? In Cloud Shell, it will work. If I use this in Cloud Shell, it will work. What is the reason? Why it is not working here from my local system?
need to authenticate first, right?
Yeah, so first I need to log into my account first. So how will you log in? AZ login hyphen use device. What is it? Device code, right? So now take this URL, go to the browser and take that particular code and give it here, and then next. Accept this account, continue, and then done. If this is successful, with this command. Who is trying to log into this particular CLI? By this user. He is the admin, global administrator. In general, we log in with our own user accounts. For here, I'm trying to do like this. Okay. Now, what I can do after this was done. Now, if I execute this command, it should work. You can see. After this, I have to execute this. Okay. What this command is doing right now, this command is important for us. It will download the kubeconfig file. Okay, what is kubeconfig file? Why it is so important? Because if for you to communicate to your Kubernetes cluster, to deploy some application or to fetch some information or whatever you want to do on Kubernetes cluster, as a person, I need to have a kubeconfig file. Okay, so that kubeconfig file will be downloaded to your local system from by using this particular command. Okay, so it will download to your local system right now. You can say it is downloaded and it is saved here. Okay, by default. What is this file and all? I will discuss that later. But this file is important for us to authenticate to your API server. Okay, now if I execute kubectl command, let me see if I have this installed or not. If it is not available, it is installed anyway. So kubectl, okay, get nodes -o void. Now you can see your two nodes. You can see Ubuntu 18.04 it is using, and what Kubernetes version I have selected, the same thing got installed. Right? You can see only your worker nodes. That's it. And which container runtime it is using? Container D. Okay. So that's how it is. So with this, we have deployed our Kubernetes cluster in Azure, and we are able to communicate to our Azure Kubernetes cluster from our local system. Okay. This is the one which I want to show. If you just want to test it, simple. I can follow this particular commands directly. I'll just tell you later what is this. Oh, I just closed it. Okay. We can just deploy this particular sample application. We'll see that on Monday. Okay. What is this sample application? Without telling that, I cannot execute this blindly and show you how this application is getting deployed. Let's understand what is pod. Okay. What is the meaning of the pod? What is that? All these things we'll understand. Okay. So there is one node pool which we have created. If you want to see that particular node pools, click on here and you will see this. You can see now this is the node pool. If you want to see how many nodes are there inside this pool, click on this. You will see the number of nodes. Okay, you can see 2/2 nodes are ready. Okay, maximum pods on each node. There are two nodes which are running right now. You can see. If you want to increase now, you can just increase. Okay. That's all. So there are simple things which you can do, and this is running with Linux operating system with this Kubernetes version. Like there are so many things which you can read and understand. Let me just explain one by one later in the upcoming sessions. Okay, let us not go everything by today. Let us learn one by one in a step-by-step order. Okay. So that's all for today. If you have any questions, we can stay back. Meanwhile, let me try to delete this cluster. So yeah, that's all. Okay, in the background, it will get deleted. Any questions to be answered by me or any doubts that you have from the previous session? Thank you. So try to do it from your end as well and let me know if you are facing any challenges. Okay. Thank you. Thank you all.